Hello everyone, welcome back to the session. Sorry for the delay. There was this fluctuation in the internet, that is why we started a little late. But anyway, hope you're all healthy and are doing good. Hello Mohammed Sadiq, how are you? Um, Hope you guys can hear me clearly and my voice is clearly audible. Also the screen is clearly visible. Fine, then without any delay, we'll directly move into the chapter or the topic that we would have to talk today. Okay. And yeah, as you've already been knowing that we have been doing this particular course where we were talking about the IIT JEE 2022 preparation, and we're discussing the chapters as well in detail in the level that you would need for IIT JEE preparation. Yeah. So for those who have not prepared the topics well, do subscribe, like, and share the things that we have here so that you and your friend would get access to everything for free. Okay. So that I've been hoping that you're doing that. We also have this Telegram channel. You could join us there. And with that known, let us just start the topic. As we have been discussing about hydrocarbons for quite some time, we know already, right, that what are hydrocarbons, how alkanes are going to be used up as a hydrocarbon, right? We had seen the reaction of alkene and alkynes as well, right? Majorly alkane and alkene we had seen. We would be continuing with alkene now, be understanding about the way an alkene reacts and produces or prepares something. Also, one thing, children, that whatever we are doing, whatever effort we are putting is all for you. So utilize the benefit that your teachers are pouring on for you and your preparation. So utilize that, like, share, and subscribe. Yeah, Muhammad, for now, yes, you are, I think. But then anyway, get the benefit of whatever you're learning. Hydrocarbons, we will start. But yeah, before starting about me, this is me, Gyanendra, and I have been teaching in different places like FitG, Narayana, VMC, and I have been teaching in this field for around 7 years. So I know what about the things that we have, the portions that you would have to do, okay, for your preparation of IIT. Anyway, let us directly move and talk about the topic. And before talking about the topic, it was alkene that we were discussing in the last session, right? So we'll be continuing with alkene and learning about the things from that. Okay, so these alkenes are simply a double bonded molecule and it is unsaturated. So we had seen the reactions with which you prepare an alkene. Now what we would be looking for is the reactions of an alkene. Okay, children, we have been seeing how do you prepare it, what is it that you use in order to prepare an alkene, right? Those parts and those things are multiple ways in which you could prepare an alkene. One such way is by oxidizing something. The other way is by substitution reaction, by substituting something. And then you could also see the reactions by which alkene or with which alkene reacts as substitution, oxidation, polymerization. The polythene that we use can also be prepared or would also be prepared only from this alkene. Then we had seen the addition reaction, or we will see the reaction which we know as addition reaction again. Okay, as you already know, addition of hydrogen happens over the alkene molecule, right? So those types of reactions are what we will be observing. So let us directly move into the reactions and learn about them. The first reaction that you would need to understand is hydrohalogenation reaction. As the name suggests, hydrohalogenation reaction would literally mean addition of hydrogen and halogen. Okay, hydrohalogenation reaction. Now what happens here is you would add hydrogen and a halogen. Okay, so major things that occurs over here is addition of hydrogen and halogen would occur. We add a hydrogen and a halogen to the alkene. Okay, so that is what is the major outcome that you would get particularly in this reaction to the substance, to the compound. Now how and what it helps us with is also what we would observe, children. It is just observe that, understand that, and learn. Now it happens in two different ways depending upon the reagent that is present. The normal way or the normal action is something that is very obvious. Let us just see what is this obvious thing. You just imagine that you have this alkene, okay? Over here, the alkene or the double bond is over the corner. Now, in this molecule, we could clearly see that this double bond is over here. And that double bond that we can see over here is going to be the reason for the reaction to happen. Now, double bond has a lot of electron density. This electron density would see that there is a hydrogen atom bonded to an electronegative atom. Now that electronegative atom, what that thing is going to do is that thing would abstract the hydrogen from hydrogen, abstract the electrons from hydrogen, would pull the electron and keep it more towards itself. Okay, Shadik? You could ask if there is something that is not understandable. I'll try to speak slowly, not an issue too. So what I was trying to tell was, if there is this electron pair that is present between two carbon atoms, and there is this HBr, right? HBr, if you observe, this bromine is a very electronegative element. And because this bromine is an electronegative element, what it is doing is it attracts the electron pair towards itself. And for doing that, it leads or it makes this hydrogen devoid of electron. When it sucks away the electron away from it. So the hydrogen doesn't have as much of electron density as it initially had. Okay. And because of that, what happens next is this electron pair would be then given to this hydrogen. Okay. And when this electron density would be given to the hydrogen atom, hydrogen would be happy, because it wasn't happy earlier as the electron density has been taken away by the bromine atom. But as this electron density is being given to the hydrogen atom, its stabilization occurs. Okay. Now you just imagine, out of these two atoms which has been bonded by this double bond, which atom would get the hydrogen attached? Actually, the bond has to initially break. So if this bond breaks up, the electron density could either move initially to the corner or to the other edge. But let us just say that electron density moves here. So this carbon would gain a negative charge and the other carbon would automatically gain a positive charge. So it is clear that obviously the negatively charged atom would make an attack over the partially positively charged hydrogen. And if that happens, what is going to be the resultant? Hydrogen coming over here. But you could see that this positive charge would be left unstabilized. It is still going to be there. So there has to be something that would stabilize this. Now you just remember, as this bond over here between this hydrogen and bromine is is a polar bond, right? It is between hydrogen and bromine. So electrons are more towards bromine, and as you make the electron come to hydrogen, the hydrogen would be free from bromine, and bromine would take away the electrons and run away. So this bromine would take away both the electrons that are shared between hydrogen and bromine. And that is why the other product that would be generated over here is Br minus. That Br minus or any negative ion, be it having a complete octet or not, ions are not as stable alone as a simple neutral atom. So this ion would try to become stabilized. How do you think it would get stabilized? It is very simple. For that to get stabilized, you have a positive ion over the other side. Hello, Lekpal Sahab. How are you? Good evening. Now this Br minus sees that there is a positive center that lacks electron density. And this one is negatively charged. It has electron density and density alone, right? So what would it do is it would give its electron density to that atom. And once it gives its electron density to that atom, this Br would go and get attached. Now, this reaction has happened in a way that we have just now observed. Now, many people would think, sir, this electron density has shifted in a way that positive charge gets developed over the central carbon, negative charge over the terminal. Why not the other way? Why don't you make the negative charge developed over here and positive charge developed over here? If that happens, children, that is good, Mohammed Sadiq. It's good. Now, what would happen now is, when this type of bond or negative charge or charge distribution occurs, the first attack would be happening from the first atom and then would result in this Br minus. So where would this Br minus go next? Over the terminal position. Now that has happened, but then what is the outcome? I mean, what is the intermediate that would be generated in the second case? That is the one that is important, and that lets you know why the second case is going to give you a minor product. Let's say the hydrogen is attached over here. I mean, before the formation of product, I'm telling you what has happened. So over this side, you've got a positive charge. Now just tell me, the positive charge over a tertiary carbon is more stable, or the positive charge over a secondary carbon is more stable? I mean, positive charge over the secondary carbon or positive charge over the tertiary carbon, which one is going to be more stable? If you compare the stability of the positive charges in the first case over here and the second case over here, it is clear. In the first case, you have what? Could anybody see and tell me? I mean, like Mohammed Sadiq, you could also tell me, like Pal, you could also try giving an answer to this. Children, anybody could try. What we can see here is this hydrogens present over the alpha carbon atom. And if they are present over the alpha carbon atom, what we know is they will show hyperconjugation. So total 3 plus 3 plus 3, 9 hyperconjugated structures are present over the first molecule. And they would stabilize the carbocation. And the second one, you just have one hydrogen over the alpha carbon, because this is going to be the alpha carbon, as this is the center of interest. And for that reason, only one hyperconjugation would be there in the second one. Very good, Mohammed Sadiq. And for that reason, we could clearly see the second one isn't that stable, right? So which one is more stable? The first one is more stable. Very good, Mohammed. So this one is going to be more stable, and if it is more stable, the product that they would form is going to be the major one, right? So that is the catch that all of you need to have. Okay, children? So see, this is what would be the reason why Br gets attached over a place which would have more stable carbocation. Now there is a trick here, children. That trick is called as Markovnikov rule. Now what is this trick? Every student would have somehow or somewhere have heard of the trick, because tricks are the ones that you guys like. But understand that IIT JEE wants you to understand the thing, and once you understand it, you would not even need a trick to get to the answer. Very easily you could apply the concept and get to the answer, right? So here, observe that the place where bromine has been attached is the one having less number of hydrogen. There are two options that we had initially. The first option was having an hydrogen attached over here, having a halogen attached over here, and the second option was having a halogen attached over the other carbon. In the first carbon, you have two hydrogens. In the second carbon, you have one hydrogen. Remember that if you are following Markovnikov rule, because of the stabilization of carbocation, the bromine or the halogen would get attached to that atom which has lesser number of hydrogen. That means more number of methyl or some alkyl group substitution. So always remember that you could use that trick as well. But I don't suggest you to use the trick. Just remember the idea. Find more stable carbocation. Wherever it is there, that is going to be giving you the major problem. Okay. So this rule particularly of having this bromine or halogen attached over the carbon having less number of hydrogen is called as Markovnikov rule. Okay. So that is also done now. But then in case, previously what I've written here is this HBr. Now let us just imagine, children, that instead of HBr, you have in the same case, okay, with the same molecule, you have this double bond, you have the C, you have the CH3, you have a CH2 over here, you have another CH3. Okay, so we have this molecule, and now this is again not an issue. Now what would happen here is, if this molecule is reacting with HCl, if this molecule is reacting with HI, if this molecule is reacting with any of these things, it would always be giving you the Markovnikov product. What was the Markovnikov product? The Markovnikov product was the one where the hydrogen gets substituted where? Over the position where the carbocation would have been less stable, or the halogen gets substituted over the place where the carbocation would be more stable. So you could clearly see that the Cl or iodine would come always over the tertiary position. Why? Because there the carbocation would have easily formed, and they would become or make the molecule more stable. So that point is very important to be noted, and I hope you would have understood that point really well. Now that that is understood, let us move to a spatial condition. If you're considering or if you're using HBr, you still would get normally this product, okay? But then if in case you've added an extra thing, for example, if you've added an extra H2O2. Now this H2O2 is a unique substance. You guys remember I told you about H2O2. It is an open book structure, a thing that student wouldn't very well like. Not all students, some students do like books a lot. Okay, so this is an open book structure, and if this molecule comes up, we know this bond is very weak and it could get cleaved homolytically very easily and would result in free radical mechanism to be followed. What mechanism we had seen for Markovnikov was involving the formation of ion, and for that reason it was ionic mechanism, okay, because ions have got formed over here. But then in this case, when the presence of H2O2, ionic mechanism isn't going to work out. Why won't it work out? The reason being, in the presence of H2O2, free radical initiation occurs, and this molecule happens to happen in a free radical mechanism. And for that reason, the first hydrogen would get attached over the place where free radical would be more stable, okay? And for that reason, this would have the Br attached over the other position where the double bond gets over. So remember that in the presence of peroxide, the attachment of halogen would occur on the position having more number of hydrogen. In the absence of peroxide, the attachment of halogen would occur in the place where less number of hydrogen are present. Now, does it occur with any of these three things? No, it doesn't occur with many of these three things. It just occurs with only one substance, only one kind of reagent. The reason being thermodynamic dissociation and association energy. Now this HBr is the only one which would show you anti-Markovnikov product in the presence of peroxide and Markovnikov product in the absence of peroxide. So remember this thing really well, that it is this HBr that is the only one that could get attached its Br atom over a particular position depending upon the presence of an extra catalyst. If you have H2O2, it would get attached over the terminal position or the position having more number of hydrogen. On the other hand, it would normally get attached over the position having lesser number of hydrogen. Now the reason, if anybody would ask you the reason, you already have heard and learned the idea. Here it is, that the mechanism is also being explained. Initially, as I already told you, this bond gets broken down homolytically, causing a radical to be generated. Now this radical would propagate. So first step over here is the chain initiation. Now in the second step, the chain would get propagated. In any free radical mechanism, this thing would always happen. Okay. Hello Gurgulla, how are you? Good name. Hope you guys are able to understand and are getting the idea of the things that I'm talking about. Again, if you are all understanding the things, do like, share and subscribe. Also tell your friends about the channel so that they could also get benefited. Yeah, so what is happening over here is you have the chain propagating. A free radical is making another molecule like itself. The free radical doesn't allow itself to be in the form of an unstable species, right? So when it comes closer to another species, it says that that is happy, that is already stable, and I am unstable. When it goes there, good evening, how are you? So when it goes there, it would make that atom also a free radical by breaking the bond over here, okay? And when that happens, children, when that happens, what it would undergo is it would form up something called as this hydrogen getting a free radical would get attached over this, okay? So ultimately one of this ROH gets generated. That isn't very important. What is important is this Br radical, okay? There would be this Br radical generated. Now this Br radical comes closer to the alkene, and the alkene gets broken down homolytically, right? Each of its electron gets shifted, and then this bromine first gets attached to the carbon atom, and there would be a radical generated over here, right? This radical, as it is being generated later on, would get the hydrogen attached from another HBr, that is also going to be cleaved homolytically. So ultimately what has happened is this hydrogen gets attached later on, right? And what mechanism it has followed? Free radical mechanism. So the stabilization and the behavior or the mechanism that has followed is completely different. For that reason, in the anti-Markovnikov rule, in the chain termination step, this is also propagation. Okay, in the termination step, things would get terminated. So this Br radical might come in contact with another Br radical, or maybe hydrogen radical, and form Br2 or HBr again. So what has happened here is free radical mechanism has followed, and that has caused this HBr in the presence of peroxide to have an attachment over the position, the Br having an attachment over the position, which has more number of hydrogen atoms. So keep on remembering that, right? And with that, you should be able to easily answer those type of questions. One common mistake with most of the student does is they feel like this anti-Markovnikov rule can be used with any alkyl halide. And like, let us say if HCl is being given in the presence of H2O2, what we end up doing is we attach it over the place which we expect for HBr. But that is not correct at all. Markovnikov rule is true for anything. Okay, even in the presence of H2O2 for HCl and HI, you would still get the Markovnikov product. Remember that. Only for HBr, you have anti-Markovnikov rule possible, the anti-Markovnikov product possible. Other than that, for nothing. So that thing is something that you all need to have knowledge of, and hoping you would have understood it. Let us move on and learn something that is very interesting and is having an answer to what questions that you might come up with. Okay, so this kind of questions have been asked children in IIT JEE, and for that reason this is definitely going to help you. Okay, so stick more here and try to understand how is this going to help you. Okay, now the next reaction is halogenation. Many times addition reaction happen in a unique manner. One of this unique manner could be seen just now. In the presence of just halogen like X2, Br2, what happens is, like let us just say you have CH3, oh not CH3, CH2, double bond CH2, okay? Or let us just say you have an alkyl group over here, another alkyl group over here, you have a double bond over here, and another R group over here, hydrogen. Now when you bring this Br2 closer, children, haloalkanes, we have a chapter, a whole thing or a whole topic of haloalkane as a lecture. Okay, we did discuss about everything in haloalkane chapter already, and is there, the link to them is there in the description below, so you could find it there. Ujjwal, do check that out and let us know if you have understood or if you find any doubt. We have that haloalkane chapter completely covered. Okay, if there is still anything that you would want to learn, do talk to us in the Telegram channel and let us know what we could help you with. Okay, Ujjwal, hope that thing would help you in some way. Okay, now this Br, children, Br atom or Br molecule, we can say here, is going to have one of this electron pair moving towards it. Br has a lot of electron density, right? So what would happen with the electron density of Br is this electron density that is present on the bromine would be moving towards one of the carbon. What has to happen to the other bromine? It has to go away. Okay, this bond has to be broken down, and if this bromine wants to go away, it would go out as Br minus ion. Now this molecule has formed, one R was over here, one R was over here, one R was over here. Now over this bromine, because it has got 3 bonds, it would gain a positive charge. Now do you think a positively charged bromine is stable? It's like you have taken out some money from a very greedy person. You could know how he would feel. You have taken out food. Excuse me. So, you have taken out food from somebody who doesn't have a lot of food. Right? So for that reason, we could clearly understand what would be the condition they would be going through. They wouldn't be very happy about what they are undergoing, right? So they would want themselves to be away from this positive charge. Now, how could it do that? How would it become neutral? In that way, what would happen is this Br has to come. But can the Br come from this direction, which is already covered up or binded by this bromine? No. So this attack isn't going to happen. Why? Because that side is hindered. So where would it attack from? It would attack from here. Here also it has two options. What are the two options, or the two possible options that it has? One of the possible option is it making an attack over here. The other possible option is it making an attack over here. The B option. Now, depending upon where it makes the attack, the other bromine atom moves away to the other end, right? Because it breaks like this. So one of the bromine comes over one place, the other bromine comes over the other place. So let us just say the A attack is going to happen. Then this bond over here gets shifted to the bromine atom and would result in the formation of something like this. So this R stays over here, this R stays over here. This R gets pushed over here, and this new group that has been approaching, this Br comes over this place. Okay, the Br comes over this place, and then this other Br that has been joining is obviously moved over here. So we could clearly see that the bromines are properly in the anti position from each other. So what kind of addition has occurred over here? Anti-addition. So if anybody would ask you, how do you prepare anti-addition product of dibromine or dihalogen? You do this. That's the only way. Remember one more thing, children. In this process, the medium that you would take is a non-polar medium. Okay, a medium that isn't going to give you water. Also non-polar, non-aqueous medium. So why don't we take water or a polar medium? Why we don't take that is because they have high electron density. And what happens if we do take that is, after this state, we would reach this state, that's good. But then because water is going to be present there, water wouldn't wait for this other Br minus to attack. Because it is free from the beginning, it would just like that make an attack. It could make an attack over this atom, it could make an attack over the marked blue atom. So wherever it attacks, on the other direction, the Br would get pushed, right? So what has happened here is HOH2 or H2O has been attached over this carbon, and for that reason this Br is being pushed away and it has been moved to the other carbon, right? And what has happened to this oxygen? Because it has made 3 bonds, it is not stable. It has got a positive charge. So what do you want? You want this positive charge to be stabilized or not? Always remember, an atom which doesn't want the electron to be given out doesn't like to be positively charged. So out of these 2 hydrogens that are attached with oxygen, what would happen to them is, one of the hydrogen is going to be taken out. By what? By water molecule that is already present. So this water molecule takes out the hydrogen, neutralizes the positive charge, and converts itself to OH. Now where is this water molecule coming from? Guys, this medium itself is water. So you don't have any deficiency of water. So this water molecule can easily be coming up, right? And that will result in the formation of this OH over here and this bromine. So that is the catch, and that is the difference. And you know why we don't take water is because we don't want OH to take up one of the positions of the bromine, right? And always remember what kind of addition has occurred over here. An anti-addition. If one bromine is attached over the top, over the carbon, the other bromine would get attached over the bottom, over the adjacent carbon, on the adjacent carbon. So that point is to be kept in your mind while you're doing or trying to attend or write a solution to this type of question. Also remember one thing, if in case you do the reaction in a medium like water, OH would take up the place of one of the bromine. But sir, if we don't take water, what if we take, let's say, other than water, what if we take ammonia? Then what would happen? Then guys, instead of this OH, you would just have NH2 group over here. That is the only difference that you would be observing. So this thing is what you would need to remember and you would need to be using. Hope you guys would be using it and would try to get to an answer, right? Do let me know if you've understood this or you've got confused somewhere. Remember that this is an anti-addition and it's a very important reaction, also one of the important reactions. Okay, so hope this thing and this idea is really clear to you and you've understood the concept. So with that known, let us move further a little bit and try to understand more of these things. Okay, children. The next thing that you would need to understand is the oxidative cleavage reaction shown by the alkene. Now, what is this oxidative cleavage reaction? A reaction where this bond gets completely cleaved. in the presence of some reagent. There are different types of reagent, like ozone can be taken, KMnO4 can be taken, OSO4, this type of things can be taken. What they do is they break it apart. How? Different mechanisms were taught for this. Let us just see the normal mechanism that they do follow. The easier one, the actual one. What happens over here is, because oxygen has a lot of electron density, ozone, if you might not know, this is how ozone molecules exist. Okay, you would have a positive charge over one of the oxygen, negative charge over the. So it has been loaded out with a lot of electron density, children, and because it has got a lot of electron density, it would give its electron density to any atom that is having a need of it. Okay, so that has happened over this first step. What is happening there is the electron density from oxygen is moving to this carbon, and that caused the other carbon to lose its other density to the oxygen atom. For that reason, this bond would move to the, so this one would give electron to this carbon or double bonded carbon, and this double bond would move to this oxygen. So that has actually happened over here. And when that thing happens, we create something like this, a complex like this. We call it molozonide. Okay, this molozonide isn't obviously stable, has a lot of oxygen, so that bond very easily gets cleaved. How does it get cleaved? This bond from here moves to this place and cause a double bond to be created between carbon and oxygen. But for that to happen, one of the bond between oxygen has to break down. So this bond breaks very easily and moves this oxygen, or get this oxygen the electron density. And with that happening, this molecule would shift, or this electron density that would be gained over here would result in another bond creation. Okay, it all has initiated with this electron pair moving to this oxygen and carbon bond. So here also you'd have got another double bond. Definitely, team PUBG, we have, or we will definitely be giving this lecture in Hindi as well. For the Hindi session, we will be live on 8 p.m. or at 8 p.m. in the same channel. So don't worry about it at all. Okay, Hindi is our major language, so definitely we'll be coming up with that. But anyway, not major, we can say whichever is needed, whichever is one you're comfortable with, you could learn with that. But anyway, coming back to the point, this bond over here, children, gets broken from this place. Like this bond gets broken, and a new bond over here and a new bond over here gets created. So this molecule results in the formation of this and this. Now this is okay, this is stable. But this molecule, which is in circle, isn't very stable. So this molecule further undergoes another progress where this would again attack the carbon. Okay, this molecule would again attack the carbon, and this would get flipped. I'll just show you over here. We have flipped this CO bond, and with this flipping of the CO bond, what happens here is this oxygen gives its electron density to carbon, and with that reason, this double bond would move its electron density to this carbon. And that again would cause this double bond to move from here to here. And that would result in formation of another cycle. And this cycle, you know, what do we call it? We call it the ozonide. And this ozonide is again unstable. This is a long mechanism, so don't worry too much. But then what happens next is this bond, this bond gets cleaved from this direction, and this bond gets cleaved from this direction. And you'd get a double bond created over here and a double bond created over here. And this oxygen over this place would be taken up by dimethyl sulfur, and that would get converted into dimethyl sulfoxide. So this would get bonded with sulfur, causing this and this dimethyl sulfoxide to be produced. CH3, CH3, S double bond O, CH3. Hope you're getting the idea of this, children. So what has ultimately been prepared here is this C double bond O group, and 2 moles of that has been prepared, since both the carbons are directly attached with just a double bond. Okay, and depending upon whatever group you may have over here, you could get different type of substances being produced from this. Okay, so this is what you would need to understand, and how the oxidation occurs using just ozone has to be known. So I hope you've got the idea of this as well. With that known, let us move further and see the other reactions. As I already told you, in the presence of KMnO4 as well, you could see reactions of this kind. Okay, and depending upon the temperature and type of medium that you take, it could give you 2 different types of product, particularly KMnO4. Okay, if you take hot water, the bond breaks and gives you a similar product as of what we got in the ozonolysis. But if you take cold water and basic medium, then what happens is it gives you 2 OH instead of that double bond O. So it won't get oxidized to such a level that it had happened earlier. The mechanism is also simple. Both the oxygens of manganese, when K plus leaves, and when O4 minus becomes the one that is actually there, and this oxygens comes up and binds in the addition manner, and then would result in the formation of this OH. The same way OSO4 gives its oxygen in Syn addition manner. Okay, and if that is happening, what it gives you is this OH over this place. So it doesn't matter if you take KMnO4 or OSO4. If you take cold water and lower pH, then it would result in the formation of this OH glycol, I mean 2 OH groups on the adjacent carbon atoms. Remember that and use that. That is what would help you in order to understand and get to an answer of this kind of question. Hope this has cleared the idea of how does this thing work out. But sir, if you take cold water, this would produce it. But then what if you take hot water? Hello Manoj, I'm good. How are you? Omicron is going. Omicron is Omicron. But anyway, what is happening here is, in case when you take KMnO4 and hot water, it would result in oxidative bond cleavage reaction, and then the bond breaks up and would result in the production of same product that we had in what? In ozonolysis. Okay, I'm good. Gurgulam, how are you? Hope you guys are understanding this, although this is something that you have been knowing, right? Do let me know if there is anything that has confused you or you want my help with. Okay, so let us move further and see the next reaction. The next reaction, children, is simply this polymerization reaction. You know, polymers can also get formed very easily with alkene or substituted alkenes. One thing like the polyethylene, polyvinyl chloride, these are all some polymers, addition polymers made up of alkenes. Okay, so they get very easily formed using them, children. What happens here is this double bond breaks, and with them breaking, it would keep on joining n number of times. And with that, what we get is that polyethylene that we used to use earlier. But due to its non-biodegradability, we don't use polyethylene anymore, most of the cases. So that is the idea that we have to understand and remember. We'll see this polymerization reactions in polymer chapter. So now the next thing that you would need to understand after understanding about alkene, as we are like thorough with alkene chapter, we've understood about the reaction of how alkene reacts, how alkene gets prepared. Now we can understand another important topic of this chapter, that is alkynes. You all know an alkyne, and you know what is the structure, what is the difference of an alkyne which is comparatively to that of an alkane or an alkene. It has a double bond, right? Or does it have a triple bond? An alkyne has a triple bond. So this alkyne molecule, because it has a triple bond, the bond length of alkynes are going to be the shortest, right? Because they have 3 bonds holding each of this carbon atom with each other. They are very close to each other, and because of being very close to each other, they would be bonded really well. So for breaking them, you would need extra effort, right? And because you would need extra effort, you know, their reactivity would be different again. Now, you know, because the bond, I mean, there is a triple bond present over here, the bond angle is 180 degrees, right? And the kind of hybridization, since 2 sigma bonds are present over here, is going to be sp hybridized, right? Why is it sp hybridized? There are 2 p orbitals that are left unhybridized, right? Is because you have to have 2 pure p orbital present. Why 2 pure p orbital is needed to be present is because if 2 p orbitals aren't going to be present, you are not going to have what? You're not going to have 2 pi bonds, right? For the creation of 2 pi bonds, you would need 2 pure p orbital. So that is why this p orbitals was important. One I've already shown over here. Hello, real God. How are you? One bond over here on the top. Good evening. Good evening. So this bond would be bonded, and this bond at the bottom would also be. So you have two pi bonds. For that reason, two p orbitals need not get hybridized. If they would get hybridized, they would never be parallel and would never result in pi bond formation. That is how this alkene is different from alkane and alkene. I mean, alkyne is different from alkane and alkene. But anyway, that is not going to be asked to you in an IIT JEE question. What is going to be asked is the way you prepare it, is the way they get reaction, right? So to prepare an alkyne, various methods can be used. One such method is by using calcium carbide. Okay, we know calcium carbide can be a substance that could help us prepare. Other substances from vicinal dihalide or even geminal dihalide can use this thing or get this thing prepared. We'll see how. But the geminal dihalide need to have two hydrogens. Okay, so the first preparation method where we use the calcium carbide is in the case when you use it to prepare an alkene. How? What we do in case of calcium carbide is we bring this calcium carbide CaC2 close to the substance like water. Like you already know, calcium carbide is a substance where carbon is present in this type of form, right? A triple bonded form where both the carbons have triple bond present with it. Now this bond can easily be broken down, okay? And what happens here is this bond over here gets broken and new bonds gets created with hydrogen atoms which were attached to water earlier, okay? So there would be this new bond created with hydrogen from both the sides, children. You would get this hydrogen created over this side. You'd get this hydrogen bond with hydrogen created over this side. So ultimately what has happened with that carbon is it is getting a hydrogen attached over both the corners. And this bond with calcium would very easily break. The reason being is what calcium is going to benefit afterward. The calcium atom is going to be left out with two of these OH minus ions. And you know calcium is a 2 positive ion. So what would it do with this 2 OH minus is it would form CaOH twice, which is a stable substance comparatively. And that is why this thing happened in this manner. Hope you've got the idea why and how this calcium carbide reaction is. This is not an important reaction, but yeah, it is good to know more, right? It is good to be a warrior in a garden than to be a gardener in a war. So we have this next reaction that is using the vicinal dihalide. A vicinal dihalide, guys, you already have learned that is the one where the halogens or the groups are present over the adjacent carbons. If both the groups are present on the same carbon, it is going to be geminal. So here it is a dihalide which is vicinal. If it is vicinal dihalide and it is going to react, in the presence of NaNH2, NaNH2 would end up giving you a base which is NH2 minus. Now this base NH2 minus is going to make or remove a hydrogen. Initially what it would do, one of the NH2 minus would take out this hydrogen, causing a double bond to be created and this Br to be leave. Or it is actually happening because of this attack, since the double bond is found in between and this Br has left. So that Br has left and you've got this additional double bond here, but then you still have another equivalent of NH2. Now with another NH2 minus ion being present, the other hydrogen would also be taken down and another bond would be created and you end up getting a triple bond. So such a simple method is going to be used in preparation of this alkene from vicinal dihalide. I hope you have already got it. Now one thing you should remember is initially you can take a weak base, okay? In the beginning when you want to remove the first halogen and hydrogen, you can take a weak base. But the second base has to be really very good because that has to take out a hydrogen from an atom which has already lost its hydrogen, right? So that is going to be a little difficult. That is what you would need to understand. But anyway, these things are going to be happening very easily if you have some vicinal dihalide, okay? Even a geminal dihalide can work. So this is the point that you would need to understand and you could be using in order to get the product that you would want. Hope you are getting it. Also, yeah, do stay with us, stay tuned. We are having very good things coming up for you. This is all for you only and for your preparation of IIT JEE. So do subscribe, like, and share the channel and the course that we are having here. Anyway, this is the molecule that we have got, and in this molecule, with the presence of a base like KOH in a medium of an alcohol, again, you know, alcohol, if you'd see what kind of reaction that substance is going to give, it is going to give you a action of a base, the action of a base. So OH minus would again act as a base, would take out this hydrogen, make a double bond, remove this bromine, then attack the other hydrogen over the other corner, okay, result in ultimately forming this. So this is what you should understand. When you come across such substrate and such a reagent, your idea should automatically, this idea should automatically come that how and what way is this reaction going to happen. Okay, with that known to you, you could easily conclude about the outcome. So that is the point that is important to us. But the next thing is the chemical properties. What are the chemical nature? What are the chemical properties that this thing shows? Now there are many addition reactions that we have already seen, like hydrogen can get added to double bond the same way hydrogen do get added to a triple bond. HBr does also get added up to a triple bond, even Br2, and this diborane B2H6, that's an electron deficient species, because boron has to have 8 electrons, but in that bond it doesn't have that. So it would gain the electron. Hello Sachin, how are you? So in that molecule, like if you observe the C triple bond C, you could clearly understand that whenever a thing that requires or that demands electron like B2H6 or simply BH3, it gains electron density. Okay, so the reaction moves further because of that. And then HOCl, which can be another useful thing that could show the reactions. Okay, then HCl, these are all going to be showing the normal reactions. And then one very important reaction that is shown by an alkene or alkyne is Diels-Alder reaction that would pose a giant or aromatic or organic molecule to be generated. So these are the things, children, that you would need to have an idea of. Let us move a little more and try to understand few of them. The first reaction is hydrogenation. As you already know, as the name tells you, hydrogenation means addition of hydrogen. Now you would remember, if you just like that add hydrogen in the presence of PD, platinum or nickel, you end up getting an alkane, right? So if you don't want to get an alkane, initially you get an alkene, but with further presence of this substance, you end up getting an alkane. And this is going to be a Syn addition reaction, remember? So here, depending upon what you want, you may take Lindlar catalyst or not. So it all depends on what you need. If you want an alkene, take Lindlar catalyst. If you want an alkane, leave Lindlar catalyst, just add palladium or nickel or platinum in the presence of hydrogen, which is occluded over it, which is binded over it. That is what you would need to have. So, hoping that is clear to you. And what is Lindlar catalyst? It was that substance that restricts the reaction to go to completion. It halts, it stops the reaction over the formation of alkene itself. What was that? Palladium in the presence, palladium hydrogen in the presence of barium, BaSO4 or some other suppressant or depressant. The other thing is, this also shows the Birch reduction, like this Na in the presence of liquid ammonia. You could simply see the Birch reduction as of how we had seen in case of alkene. Yeah, 2 times, total 4-step reaction would be that. Okay, 2 times this thing has to have its own action acting. First to make up one of the bond broken down, and then on the second, right, children? So we would have the similar reaction as we had seen in that alkene chapter here as well. Next reaction is halogenation. We remember how alkene attacks over the halogen, right? Initially it gets this 2 halogen attached in this manner. So one over here, the other goes out and comes over the other position. So that would result in this 2 halogen. And then again, because there is still a double bond, that would again result in substitution of 2 more halogens. So what would be the outcome, which is different from the previous alkene, is you would end up getting 4 of these groups attached to the alkane, to the alkyne chain. Since there are 3 bonds, this 2 bonds has to get broken down. So these are small things. If you get a catch over them, you could very easily be able to predict the electrolysis. Now, as I already told you, BH3 or B2H6, if you say, these are those substances that lack electron density. So how do we know a substance lack electron density? Guys, to know, you draw that substance. Now, if you look at this substance, you can see that boron has how many bonds? 3 bonds. Then how many electrons are going to be there? 6 electrons are going to be there. Definitely, it has a need of electron density. In fact, it is a Lewis acid. So for that reason, this electron pair over here would be given to this boron. Remember which electron would be coming over here, and which atom would be attacking over here? A less hindered atom would try to attack, because boron has this flanking hydrogen atom. A more hindered carbon cannot easily give its electron density to the atom. So when this boron comes, it gets attached to the terminal position, and in the presence of peroxide, in the presence of a base, would result in the formation of this OH group initially with a double bond. That would undergo tautomerization, where the double bond shifts over here and hydrogen moves over here. So this would result in the formation of an aldehydic group, children, a carbonyl group. So understand how the boron's presence can result in formation of a unique compound. This is going to be a hydroboration reaction. We had seen hydroboration reaction, or we will again see this reaction really well in detail, and we would understand why and how this can happen. There are 3 variations to this as well, children. Instead of this NaOH, if you take an acid, the reactant, or the reagent would be the product would be a different one. So we would again observe this when we would be learning about the preparation of alcohols. And alkane can also be prepared when you take an alkene and react it with BH3. Do let me know if you want to understand about that reaction, which we call as hydroboration oxidation reaction. This is hydroboration oxidation of alkyne. I'm talking about hydroboration oxidation of alkene, which is more famous. Okay, so do let me know if you want to learn that with mechanism. The next reaction is hydrohalogenation reaction of alkynes. Here again, because it is having 2 bonds which can be broken down further, this Markovnikov rule gets repeated 2 times, and that would result in the geminal dihalide preparation. No difference in mechanism, the one that we have learned would happen. Halogen goes to the place where less number of hydrogens are present. Unless this halogen is bromine, that is HBr, and it is happening in the presence of peroxide. In that case, what would happen? The substitution happens over the other atom, the atom where more number of hydrogens are present. Hope you're getting this idea, and you've got how do we actually attempt it or try to get to the answer of it. Do let me know if there is any confusion. I'm not talking about its mechanism. The reason being, in the last class only we did talk about the mechanism of Markovnikov or anti-Markovnikov rules. Hello Kunga Kajuria, how are you? Welcome back to the same batch. Good to see you here. Hope you're all studying well and you're all doing whatever preparation you guys are doing, right? Okay. So let us try some problems, and better if it is from ITJ, right? The major product of the following reaction is, the reaction, this question was asked in 2020. So just imagine, like, you would need to use this and you would need to try this yourself. The major product of the following reaction is, what is the reaction? The molecule is being reacted with HBr. Now, if it is being reacted with HBr, you could clearly see that the double bond has to, the double bond has to break, right? How does it break? If you see HBr molecule, if you see HBr molecule, what this HBr does is, this HBr breaks in this manner and this bromine comes up. Good evening, Kunga. Now this Br minus would obviously go to a place having less number of hydrogens, right? And that is over here. The same would happen with the other HBr. When this gets broken, where would this Br go? When initially, observe that here would the carbocation, now if you try to use the same Markovnikov rule and try to think about the product formation, you'll make one mistake. The mistake is, we need to see where the carbocation is more stable. Hello Braj Mohan Shukla, how are you? So we would check out, would the carbocation be more stable here? Then if you'd see, this NO2 group is a minus R group. Hello, hello, man. So what happens over here is this is going to withdraw the electron density. So NO2 group is not a good group because it removes electron density, and that's why you would never have this positive charge developed over here. So where would the positive charge develop? It would develop over here, and the attack over the hydrogen happens from this place. So for that reason, bromine, instead of getting attached to the place where less number of hydrogen were present, it is going to get attached to the place where positive charge is more stable. For that reason, while teaching you about Markovnikov rule, I was telling you that reason, how to find out what is the actual outcome. Okay, so hope you've got the idea with which things happen. Hello Brijmohan, how are you? So remember that, and that is why which option seems to be a possible one. Let us just check it out. It is D, and it is definitely D. Brijmohan, we are not going to learn English here, especially in my class. We will be learning just the chemistry. Okay, I mean, yeah, we can take your idea. We'll try to keep some English sessions as well. Yeah, not by me though. But anyway, hoping you've got the idea how this bromine is going to get attached over this place and why it is on that place. Even without, okay, you have an English exam coming up. Yeah, I'm sorry and understand that your English exam is going to come. But yeah, let's think something about it. Hello, Alu Sharma, how are you? Good name. Is it really your name? Anyway, so this is what happens. Now there is this other compound. When how are you, by the way? The other question. Okay, this is also asked in 2020. See, two questions from same chapter in 2020. The major product formed in the following reaction is, okay, the reaction is simply in the presence of HBr. Now you could see here there are multiple options given. How do you approach it? Let us just try to see how do we approach it. We'll first draw the molecule properly, and we'll see which one is more preferred one. CH, okay, and then 2CH is going to be attached over this. So this is the molecule, sir. Now if this is the molecule, you would normally try to have an attack over this method, that you get this hydrogen attached over here and the bromine has to have an attachment over here. But when the positive charge develops over here, well, that is really a great thing, Alu. Good name and good reason. But anyway, good to know. Fine then. That's great. So what has happened here is, if you see that carbocation, what's the carbocation generated? You know, carbocation is going to be what? Is going to be more stable in a place like this. So this hydrogen from here can be shifted, children. There is a possibility once it gets shifted over here, where would that bromine atom come? The Br minus goes over the new position. That is where the carbocation is more stable. So you would get this CH, you would get this C plus, CH3 and another CH3. And then this Br comes in, okay, and when this Br comes in, you get this molecule, right? So seems like we have got the answer already. So out of these two possibilities, the answer is going to be the one. When one of the possibilities is over here, the other possibility is over here. Let us understand, like we can understand that this is more stable carbocation, and for that reason, that is going to give you the major product, right? Always remember, the more stable carbocation gives you more stable product. But when you get free radical, when you get the carbocation formed in the mechanism, if the carbocation doesn't get formed, how would you decide the outcome with carbocation, right? So always keep a look and have that thing known to you, that a carbocation is the one that helps you decide in case a carbocation is getting formed in the reaction. If it isn't getting formed, it isn't going to help you. Fine, then we have another question which was again asked in 2020. Which of the following compound product an optically active compound or produces an optically active compound on hydrogenation? Now we know what is hydrogenation, right? Addition of hydrogen, and which would give you a optically active compound. Now for this question to be answered, you guys need to be thorough with what is optical activity, which I believe you might be. Okay, so what happens here is when you add hydrogen to this molecule loses the double bond, This molecule loses the double bond, this molecule loses the double bond. Love you too, Alu. And this molecule loses the double bond over here. Now what happens next, children, is we would need to check. To check the optical activity, there are two things that you should check. First, does the compound has a chiral center? If it has a chiral carbon atom, check if the molecule has any type of superposability. Does it have symmetry of any kind? Okay, now let us just see. If you see around this atom, you could see that over this side and over this side, two different types of groups are present. So this is definitely chiral, and not only chiral, it is even optically active. But over here, if you see, you have ethyl group, and 1, 2, 3, you have propyl group. So the following products produces an optically active compound on hydrogenation. So if this gets hydrogenated, you have 3 carbons over here, 1, 2, 3. You have 1 and 2 carbons over here, hydrogen and hydrogen. This also seems to be optically active since different groups are there, although I think they have missed one of the carbon over here. The next one here is over this place. Over here also, if you check out, once the double bond gets lost, okay, this is again going to be a different group. This is a different group, so this is also optically active. And the last one, it is not going to be optically active. The reason being these two groups are same, right? If that is the case, which one is not optically active should be the question. Okay, products are not optically active. Okay, if it is not optically active, we saw that this one would be optically active since it gives you two different types of product, as I've already told you, right? This is optically active, this is optically active, and this has symmetry. And because it has symmetry, it is not optically active. Okay, and here they are talking about not optically active substance. This is the way, children, we have understood with which we can solve a problem, right? We have now got an answer. Why is it this optical activity that you could easily understand or you could get? Hope you've got the answer to this. Okay, then we'll move further and solve more questions here. One question is for you to try. It was asked in 2007. Give this a try. I have attached an answer to this. Don't check out the answer. Just check out the question. Which of the following reaction will yield 2,2-dibromopropane? Okay, so try to see this, try to do that, and get an answer to me in the chat box or the comment section. Okay, yeah, even I do like that. It's true. So this is the point, children, that you would need to remember. Remember that, not to check the question, the answer of this question. Do find out the answer yourself, and do let me know how did you get that answer, either in the comment section or in this Telegram channel. We are going to be available for you over here. Do like and join this channel. Also let your friends know about our channel, and do ask them to check it out, get the answers and help wherever they need for their preparation. We'll be coming live daily and bringing this things for you, preparing. We are doing it all for you and for your success and your exam. Yes, obviously, if you get success, we would get our name. So that is what we want. But anyway, this is it that you could where you could connect with us. Also, do like, share, and subscribe. And if there is anything confusing you, if you want to ask anything which you want or which you have a doubt at, you could let us know over here. Okay, share it with your friends as well for them to be knowing. Take care, children, and all the best. Let us meet in the next section.